Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, sections 1, 2, and 3. All 51 videos from those 3 sections have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. We are now at section 6, algebra. This is the 18th of 22 videos. Hopefully I should finish that before this month is ended. Section 7, relations, functions, and graphs by October 2025. Section 8, geometry and trigonometry by November 2025. And finally, section 9, vectors and matrices by the end of this year, December 2025. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. Since this video involves quite a lot, I will quickly scroll through most of the typical introduction. Okay, so far we have completed 17 videos. Those have been published in their entirety on YouTube, and these others only partially published. I am now at video 18, which is objective 17, and when this is finished, it will only be partially published. So as I said, we are at objective 17. And it says solve word problems. And in this blue box here, it specifies what word problems. Word problems involving linear equations, linear inequalities, 2 simultaneous linear equations, and quadratic equations. And furthermore, to apply these to other subjects such as supply and demand functions in business studies. Now that's a very tall order for one video. So obviously we will only be able to consider a few examples of each case in that sequence. So we will begin with linear equations, then linear inequalities, and so on. So how is this different from what we have been doing all along in this section on algebra so far? The emphasis in this objective is your deriving those equations and inequalities from plain, simple English statements. Think of it as a form of translation from the language of English to the language of mathematics. After deriving those equations or inequalities, then we will need to solve them to get usable and meaningful information. But we already know how to do that from objectives 10 to 16 in this section. Recall objective 2 in this section, which says translate between algebraic symbols and worded expressions. And I interpret that to mean translate specifically from worded expressions to algebraic symbols. Note that in this objective, all we need to do is convert word problems into algebraic expressions. That was that objective there, objective 2. Later, we will learn how to solve them. However, we went ahead and looked at that and solving it. You may recall this. I think of a number, I multiply it by 3, then I subtract 1, then divide by 4, my answer is 5. What number did I think of? We learned of a systematic way of approaching such questions. First, we will represent the unknown number by a symbol. Let that symbol in this case be y. You could let it be anything. Then y is multiplied by 3. That's the first part. After that, 1 is subtracted from that answer. And then all of that is divided by 4. And finally, we get 5. So we have been able to translate a worded problem into an algebraic expression. Now, after we do that, we then have to solve it. So as I said, after forming the equation, we now are required to solve that. So using LCM, and we went ahead and solved this. We have seen this before, so I wouldn't spend much time on it. Normally, you need to show your working, so we got y as being 7. And remember to always verify your answer by substituting in the equation, as in 3y minus 1 divided by 4 is equal to 5. Substituting 7 for y, we find that on the left-hand side, we get the same number as on the right-hand side. So we know that 7 is correct. So now, we are looking at linear equations. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. In objective 1 of this section, use symbols to represent numbers, operations, variables, and relations. So we are looking at linear equations. So recall this one here. We have looked at this so many times. Charlie and the 100 students. Charlie was sitting on a bench in a park when he noticed a group of his fellow students walk by. He shouted to them, "Hey, you 100 students, where are you off to?" One of them said, "We are not 100. It takes twice as many, plus half as many, plus quarter as many, plus you to make 100. How many students were walking by?" So we said we will represent the unknown number by a symbol. Let it be n. And then we will convert the word problem into an equation using this n. So twice as many plus half as many plus quarter as many plus 1 equal to 100. And then we solve that equation. By now you know how to solve it. I wouldn't go through this all over again. And came up with 36 students were walking past Charlie. When we tested our answer, 2 times 36 plus half of 36 plus quarter of 36 plus 1, do we get back 100? The answer is yes. So we know that 36 is correct. That was example 2 of linear equations. Those were 2 that we already did. So those were 2 examples of linear equations from previous presentations in this section. We will now consider 3 more examples of this sort, linear equations. Example, what 3 consecutive even numbers have a sum of 174? So as we said, we will represent one of the unknown by a symbol, and in this case, it would be easiest to represent the smallest number by a symbol. So if we let the smallest number, then the next greater one will be n plus 2 because it says consecutive even numbers. So if 1 is n, the next one will be n plus 2, and the next one will be n plus 4. If we add them all up, we will get 174. So we have converted the English statement into a mathematical statement, or you could say translated it. So after forming the equation, we now have to solve that equation. And so we can easily solve this, get rid of the 6 from this side by subtracting on both sides. I wouldn't keep going through this again. We have done this before so many times. And eventually you solve and you come up with n is equal to 56. Well, if n is equal to 56 and that is the smallest even number, then the next two even numbers would be 58 and 60. Remember to verify your answer by substituting in the equation. So 56 plus 58 plus 60, would that give us 174? And yes, it would. Therefore, what we have here, those answers there are correct. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Example 4, we are still on linear equations. The length of a rectangle is 3 centimeters more than its width. If the perimeter of that rectangle is 46 centimeters, calculate its length and width. Well, again, we always begin with this. Represent the width by a symbol. And let us say that symbol is W. Then the length is 3 centimeters more, so it will be W plus 3. We know that perimeter of a rectangle is 2 times the sum of its sides. So the sum of the side would be width plus length, 2 of those, and that is equal to 46 centimeters. So we have just converted that English statement into a mathematical. Now that we have formed the equation, we now need to solve it. In other words, what is W? And if we can find W, we will add 3 to it to find L, the length. So we solve this linear equation here. You know how to do that by now. I am moving very quickly. And so you reach this point where 2W is equal to 20. So W is equal to 10. So the length is 3 more than the W, which is 13 centimeters, and the width is 10 centimeters. Let's test that. Remember to always do this. 2 times 10 plus 3 is that equal to 46. And this part in here is 23 multiplied by 2 on the outside, and that does give us 46. So yes, the left-hand side is equal to the right-hand side. So we know that these are our answers.